Good afternoon to you, boys and girls. I think we have a doubt session today. Most of you have done very well, and a silly mistake here, a silly mistake there. जब हम दोबारा देखते हैं, as we observe our questions again after the test, we learn a lot. We learn that we just committed a mistake for the heck of it. Never mind, that is what a test is for. And boys and girls, please remember that you are competing with your own self. You are your self coach. खुद देखो, अपने आप जवाब मिलेगा. If still you don't find the answer, I am always there to help you. Most of the students ask for doubts on a personal chat, and I think so many of you have helped each other by the evening also, and that is very appreciable. Despite that, I am discussing a few questions on the board. Boys and girls, in question number 7, he says, if energy, velocity and time are chosen in fundamental units, what is the dimensional formula for surface tension? 7. Surface tension is equal to K, energy to the power A, velocity to the power B, and time to the power C. I think it's a very simple one. Surface tension is force over length, which is M LT minus 2 upon L. This is MT minus 2 equal to K is non-dimensional. Energy is mL2T minus 2 to the power A. Velocity is LT minus 1 to the power B. And T is time to the power C. Let's compare mass. We have A equal to 1. Simple. पहली बार ये आ गया. Length 2A plus B equal to 0. A is 1. 2 plus B is equal to 0, giving me B equal to minus 2. And as we compare time, we have minus 2A minus B plus C equal to minus 2. You have minus 2 into 1 minus B. B is minus 2 plus C. Silly mistake करते हैं हम. मैं भी बहुत करता हूँ. Minus 2 plus 4 plus C equal to minus 2. Thus, ये देखो फिर हो गई मेरे ख्याल में से तो silly mistake. वो बड़ा आसान सवाल है यार, मेरे से क्यों करवाते हो? 4 पावर है कहीं पे? नहीं आ रही. C is equal to 4 आ रहा है मेरे पास तो. Anyways, mL2 in terms of energy, mL2T minus 2 the power A, LT minus 1 to the power B, T to the power C. Comparing mass, we have A is equal to 1. Comparing length, we have 2A plus B equal to 0. 2 plus B is equal to 0, B is equal to minus 2. And comparing time, we have minus 2A minus B plus C equal to minus 2. Minus 2 into A is 1. Right? A is 1. Minus B. B is minus 2. Minus 2. Oh, this is plus 2. This is, see? मैं तो बहुत गलती करता हूँ. Plus C equal to minus 2. And this gives me C equal to minus 2. C equal to minus 2. And we have surface tension equal to K. This is energy to the power A is 1 E, and V to the power minus 2, and T to the power minus 2. E V to the power minus 2. This is choice C. अपने आप क्या करो बच्चों, मेरे से मत करवाया करो. Question number 9. Again, you're committing the same mistake, please. A system of units which has alpha, kg, beta, meter and gamma seconds, then the value of 10 joules, N1. This is, SI first. Okay. M1, L1, T1 the power minus 2 equal to N2 over M2, L to the power 2, T to the power minus 2. That is 10 joule now. That is 1 kg into 1 meter square, 1 meter square, okay? Into 1 second the power minus 2. In the new system of units, we have alpha kg, beta meter square into gamma second the power minus 2. This is N2. This is 10 into the kg goes. This is 1 meter square into gamma square second square. The power is always taken to be positive. Beta square meter square into 1 second square. Goes. This is N2. Thus N2 is equal to 10 gamma square. We have alpha square. 10 gamma square over alpha beta square. Gamma square over alpha beta square. Right? This is C again. आसान है 10th in the equation p plus ab square इतनी बारी किया है, क्लास में भी किया है, असाइनमेंट में भी किया है और फिर टेस्ट में फिर डाल दिया. नहीं करता मैं, अपने आप करो. 15th is also pretty simple, please. He says in question number 15, energy, momentum and force are chosen as fundamental units. Dimensional formula for mass. Mass is equal to K is energy to the power x, momentum p to the power y and force to the power z. Please see that you are committing a silly mistake here, nothing else. Okay, mass, energy, mL2t minus 2 to the power x, momentum, mLt minus 1 to the power y, and force is mLt minus 2 to the power z. Right? Let's compare mass, x plus y plus z equal to 1. Let's compare length. Length is 2x plus y plus z equal to 0. Let's compare time. Minus 2x minus y minus 2z equal to 0. Please see you have 3 equations and you can solve for 3 variables. मेरे से मत करना. Algebra, 8th 9th class algebra, physics. Then we have question number 16th, that's the doubt for students. 16th question. He says S is equal to A into 1 minus exponential minus bx into t. Remember, exponential functions are dimensionless. Exponential functions are dimensionless. Therefore, b into L into t must be 1. Therefore, b is L minus 1, t minus 1. Which gives you units of meter minus 1, second minus 1. But girls, please see, exponential functions are dimensionless. Trigonometric functions are also dimensionless. Theta bhi angle hai. Then we have question number 17. In question number 17, this is very interesting. In the first part, he says, actually in all parts, he says y is displacement and a is maximum acceleration. That is the catch here. Sine function is going to be dimensionless. Displacement and acceleration can never be equal. Similarly for second, third and fourth. This means none of the 4 equations is right. Because we have displacement on the left hand side. On the right hand side we have a and some trigonometric function. Whatever is the trigonometric function. Trigonometric function is going to be dimensionless. And a is given to you as acceleration. Displacement and accelerations cannot be equal. And in the last choice also you have this. In third choice you have a upon t. A upon t means acceleration upon time. This cannot be displacement. Thus in all 4 choices the left hand side has displacement and the right hand side has either acceleration or acceleration upon time multiplied by a trigonometric function. The trigonometric function is obviously dimensionless. So we have question number 18 now. In 18th question, it is exactly the same thing. मैंने नहीं करना, अपने आप करो सारे जने. In a new system of units, the unit of mass is 10 kg. Length is 1 kilometer and time is 1 minute. The value of 1 joule, M1, right? M1, 1 kg. into 1 meter square ml2 t minus 2. N1 U1 equal to N2 U2. U2 is the unit of mass is 10 kg. 10 kg. The unit of length is 1 kilometer. 1 kilometer means 10 raised to power 3 meter ka square into, and the unit of time is 1 minute, that is 60 seconds. Now the error that you can commit here is we have 1 kg over 10 kg into 1 meter square. Over here we have 10 raised to power 6 meter square. This is the mistake you commit here. वहां पे 1 था, 1 का स्क्वायर 1 आ गया, 10 raised to power 3 meter का स्क्वायर 10 to the power 6 meter square into, अब ऊपर आ गया 3600 second square over 1 second square in N2. As I always tell you, there should be no unit and लिखा हुआ, and this is what is N2. बोर कर रहे हो मुझे? This is 18th, I believe now. 21. 21 he says, y is equal to, y is displacement. Given that displacement of an oscillating particle is given by y equal to a sin bx plus ct plus b. He says dimensions of a, b, c, d. Trigonometric function is dimensionless. Therefore, y is displacement, a has dimensions of length. He says a, b, c, d. A is length. B, if angle is dimensionless, then each of these terms is dimensionless independently. Thus, B will have dimensions of L minus 1 and C will have dimensions of T minus 1. That is why C and T will become dimensionless and D is dimensionless. बाकी सब कुछ भूल गया. Therefore, this is 1 by T. Interesting. Then you have question number 25. He says the speed of ripples on the surface of water depends on. The last one. पता नहीं conversion में क्यों problem आती है? आनी चाहिए नहीं. Problem I think आपकी algebra में. आप equation नहीं solve करना चाहते. मैं तो खुद ही करनी चाहता. मैं करूँ क्यों? आप खुद करो. आपने पेपर देना. Speed v of ripples on the surface of water depends upon. Velocity depends upon. Surface tension sigma to the power k. Density rho to the power p. And wavelength to the power c. मेरी फिजिक्स खत्म हो जाती है यहाँ पे. LT minus 1 equal to surface tension है force over length. MT यहाँ गलती करते हो यार. The power A. Density ml minus 3 to the power b. Wavelength to the power c. Okay, mass A plus B is 0. Length minus 3b plus c equal to 1. Equation 1, equation 2. Time minus 2a equal to minus 1. यहाँ से तो a is equal to half आ ही गया. तो वहां से b निकाल लो, वहां से c निकाल लो, पुट कर दो. That's it, boys and girls. Do not ask me कि क्वेश्चन सॉल्व कर दो. आई वुड अप्रिशिएट अगर मुझे बताओ सर ये क्वेश्चन करना सिखा दो. देयर इज द डिफरेंस. आंसर निकालना सिंपल अलजेब्रा मत करवाओ ना मेरे से, खुद करो. राइट? प्रैक्टिस मेक्स परफेक्ट. I think we call it a day for dimensional analysis, and let us move forward to kinematics today. Okay, let me start. We are just 14 minutes into the lecture, and we start with motion along a straight line. Boys and girls, slowly differentiation part. Not yet. What I'm going to start with you is very, very simple. And you have done this in class 8th maybe. But the questions are going to be very, very interesting. They're going to be more interesting. What we are going to do for at least what's low hoga? The next 2 days, including this and another 2, is just uniform speed. Uniform speed, and there is only one formula, distance over time. But there is going to be a slight difference. Like, do not just say that the speed of the body is 20 meters per second. Say 20 meters per second. It's a huge speed. Just imagine the speed. It is covering 20 meters every second. 40 kilometers per hour. Do not just say, think. It is covering a distance of 40 kilometers every hour. Even before that, even before I start with this, I'm going to motion along a straight line, right? Motion along a straight line. Remember, at the senior secondary school level, like 10 plus 1, the initial chapters of physics would very rarely contain a direct theory. We have to discuss something with you, but it will not be asked to you in that manner. Problems asked to you will be in a conceptual manner and numerical problems. Direct physics would start, say, after a month, let's say. But still, physics at this level is conceptual. You have to do your theory, but that theory is not going to be directly asked to you in the paper. But you have to understand it. You have to grasp it very well, and then and only then you will be able to answer your conceptual questions. So the way we will study is, we will discuss the topic with you in detail, make you understand the theory, do your textbook questions, conceptual questions. I will always make a PDF file and send it to you, and then we end up with an MCQ, just as we did in the dimensional analysis chapter. Do not jump onto MCQs. We have to do our theory properly, then move on to MCQs. And you realized that doing MCQ was no big deal. क्वेश्चन तो आपने करना ही है ना, रफ में करना है, यहाँ ABC लिख देना है, that's it. Okay? What do we mean by statics? सिर्फ नोट ही करना है, just for reference. कोई काम नहीं आपके पास. You can write it down though. The study of objects at rest. Study of objects at rest. Okay. Kinematics. Study of objects in motion. Sorry. क्या बात है? एक ही बात है. Statics and kinematics mean the statics and kinematics. ठीक है? Study of objects in motion. Right? Then you have dynamics. This is the study of objects in motion. Study of objects in motion. Kinematics or dynamics, एक ही बात है. You can say that in kinematics, it is the study of objects in motion without knowing the cause of motion. I hope there is no confusion. You can say statics है, dynamics है, Dynamics is kinematics and dynamics proper. थोड़ा बोरिंग है जब तक it is the application which is interesting, but we have to pass through it. Dynamics proper, study of objects in motion with the cause of motion. Note ही करना है सिर्फ. So we have statics as the study of objects at rest. We have dynamics, the study of objects in motion, which is divided into two parts, kinematics and dynamics proper. Kinematics is the study of objects in motion without taking into account the cause of motion, and dynamics proper is the study of objects in motion by taking into account the cause of motion. Now, what do we mean by reference? बहुत बारी टर्म यूज करेंगे रेफरेंस. It is simply an imaginary point with respect to which we are going to measure an event. An imaginary fixed point with respect to which we will measure any physical quantity. Say you have to measure the distance traveled with respect to something. See, I use the word with respect to something. There has to be a reference. Like I am traveling there. I am at a distance of 3 meters from this wall. I move for 2 meters. Then from the wall I will be at a distance of 5 meters. From the place where I started, I will be at a distance of 2 meters. So it depends whether you want to choose the reference as the point where you are or somewhere else. I repeat, I'm standing at a distance of 2 meters from this wall. 2 meters, okay? I move a distance of 5 meters. It means after some time I will be at a distance of 7 meters from the wall. The wall is a reference. The reference could be time also. It could be anything. Next. Meaning of t is equal to 0. Believe me, these things are very important as we will go about studying the subject. But they will never be asked to you like this in an exam. But without this, we cannot proceed. By t is equal to 0 means the instant when we begin to investigate motion, which is not necessarily the beginning of motion. This is the instant when we begin to investigate motion. It is not necessarily the beginning of motion. I'll just give you an example. Let's say you need to go to from Patala to Chandigarh. आजकल तो वैसे ही लॉकडाउन है, जा नहीं सकते. Just imagine. And you have a fight with your younger or elder sibling कि भी खिड़की के साथ कौन बैठेगा, you know, and so on. It's the usual story with every family. And as we are traveling, as we start traveling, after some time things settle down. And you decided that we wanted to measure the speed. After every 5 minutes, let's say. And it was quite some time when you started from your home. So the first time when you measured the speed, you write t is equal to 0, speed 40 km per hour. After 5 minutes, speed 30 km per hour, and so on. It would also have been possible that there was no fighting, no nothing. You just sat down in your car and decided, okay, let's begin to measure the speed. The moment you started your vehicle and you noted t equal to 0, speed 0. After 5 minutes, you will start measuring it again, and so on. So by t is equal to 0, it does not mean the beginning of motion. It does not mean the beginning of motion. It is the instant when we begin to investigate motion. That would be t is equal to 0. Now, concept of a point. A point object. Mathematically, we call a point to be something with no linear dimension. You know, a point, no linear dimension. What is the radius of a point? Approaching 0. But in physics, we refer to something as a point if its size is very small, isn't it? No comparison to the other parameters involved in the system. नहीं समझ आया? पहले लिख लो. Any object can be referred to as a point object if its size is in no comparison, बहुत छोटा है, is in no comparison to the other parameters in the system. Let me say I have this marker. I move this marker from here to here. Now the distance traveled by the marker is, well, almost the same as the size of this marker. So I cannot call this a point. But if I throw this marker with all my might to say 20 meters above, then this size is very small. It can be called a point. The Earth, which is a sphere of radius 6,400 kilometers, can be called a point in the solar system. Now you get it, huh? Another interesting example I used to give in this season is कि आपके पास तो कोई मटर के दाने हैं, 6-7 मटर के दाने, कोई छोटा कोई बड़ा, ठीक है? 6 pieces of peas. You place them all together. None of them can be called a point because all the sizes of the peas are comparable. But you place that largest pea amongst watermelons. There are 100 watermelons lying on the road and there is one pea, which was the largest amongst the previous peas. Now, you cannot see that pea anywhere. वो मटर का दाना कहीं नहीं नजर आएगा. Over there, that मटर का दाना can be referred to as a point object. Then you take the biggest watermelon and go and place it at the center of polo ground. You ask somebody, where's the watermelon? He'll say, oh, good damn, I can't see the watermelon here. Where the hell it is? Okay, there. Okay, is it a watermelon? Okay. So then in that case, the watermelon is a point object. Thus, we can call anything a point object. Its size will not matter. It will depend upon the other parameters involved in the system. A bus moving from one place to another, one point to another in the bus stand. is not a point object, but a bus traveling a distance of 100 kilometers, let's say, is definitely a point object. So it depends, okay, what are the other parameters you are talking about in the system, right? But so that tomorrow we can move on to questions. Now the motion that we are going to study, another example is, okay, object at rest and motion. Number one, absolute rest and absolute motion are non-existent things. You can never have something to be at absolute rest. पहले सुनो होता क्या है? An object is said to be at rest if its position does not change with respect to the surroundings, with time. An object is said to be at rest if its position does not change with respect to the surroundings with time. Okay, as time passes, its position does not change. And it is said to be in motion if its position changes. Right? You can write it down. You're moving in a train. There's a train passing by, You could be sitting in a train traveling at 100 kilometers per hour with respect to some tree outside, The reference is a tree. But you could be at rest with respect to a person sitting next to you. Both of you are traveling at 100 kilometers per hour, but you are at rest with respect to each other. So rest and motion absolute terms nahi hai. It is always with respect to something. On the other hand, you could be sleeping inside your car, but you are moving with respect to the tree outside. The earth is always moving. Thus, we are in constant motion. They say that we cannot even move a finger without disturbing the stars. Yep. So rest and motion, absolute terms, nahi hai. Both rest and motion or let's say, absolute rest and absolute motion are non-existent. That's a better expression, Absolute rest. समझना है आपने बस. And motion are non-existent. Absolute rest and motion are non-existent. Right? Okay. Now, this was in general about motion and in general about physics that we are going to encounter. When we study motion, the motion is that if the position of an object is changing with respect to some surroundings with time, if the position of an object is changing with respect to the surrounding with time, we say that the object is in motion. Motion can be in one dimension. Motion in one dimension. If one coordinate changes with time, if only one coordinate changes with time. We measure the motion of any object in terms of coordinates. Let's say this wall. Motion along x-axis, y-axis and z-axis. Now, if only one coordinate is changing, the example that I am taking is that the particle is moving along x-axis only. It is also possible that it is moving along y-axis only and it is moving along, or it is moving along z-axis only. If only one coordinate changes, like, you know, at t is equal to t1, the position is x1. And this is the reference. Oh, this is x is equal to 0. And at any time t2, okay, this is time here, and this is position here. Right? And at any time t2, the position is x2. At time t1, position is x1, and at time t2, position is x2. So motion along a straight line, is an example here. While covering small distances here. Motion in two dimensions. This is x-axis, this is y-axis. At t is equal to t1, the particle is at A. And it moves from point A to point B. The coordinates were x1, y1, and the coordinates were x2, y2. Right? Like this thing. At a time t1, particle is at A, whose coordinates are x1 and y1. At the time t2, particle is at B, coordinates are x2, y2. Therefore, in a time t2 minus t1, there is a change. Delta x is equal to x2 minus x1 and delta y is equal to y2 minus y1. There is no change along the z-axis. Like I am moving this hand on the board. There is no change along the z-axis. The change is moving only along. I am at zero distance from the board, and at all times I am at zero distance. See? It could be here also. I am at a certain distance from the board, but at that certain distance remains fixed. I am moving this like this, this like this. So there is a change of two coordinates. In that case, there is motion in 2D. If two coordinates change with time. If two coordinates change simultaneously with time, then we are going to have motion in 3D. This is the motion in a plane. हवाई जहाज नहीं, a plane surface. Motion in a plane. Circular motion is also an example. अब सवाल पूछोगे आप, क्यों? I'm moving in a circle, right? And the reference chosen is the ground. From the ground, I say I have a huge platform here, huge platform. It is a plain platform and it is at a fixed distance from the ground and a ball is moving here. Thus, this is motion in two dimensions. Circular motion is motion in two dimensions because it is at a fixed distance from a plane surface. But in motion in three dimensions, all the three coordinates change simultaneously with time. And I draw it like this. See? This could be the x-axis. Yes, I can mark any axis. And this x-axis is actually like this. On your hands, x-axis, y-axis, z-axis. Negative x, negative y, negative z. If all the three coordinates change simultaneously, It is very difficult to represent it on paper because paper is a plane surface. But we can imagine that the particle moves from here to here, let's say. From A to B. The coordinates of A are x1, y1, z1. Coordinates of B are x2, y2, z2. Thus, delta x is x2 minus x1. Delta y is y2 minus y1. And delta z is z2 minus z1. Happening simultaneously. I agree, थोड़ा बोरिंग हो जाता है, कल से इंटरेस्टिंग बना देंगे, ठीक है? These are the basics, and we have just described motion in 1D, motion in 2D, and motion in 3D. Motion in 3D example is like a kite flying in the sky, always changing, always varying. That's an excellent example, a kite flying in the sky. We will now pick up. We just have to study motion in 1D and 2D. 3D is an imaginary motion. In 1D and 2D, motion in one dimension would be motion along a straight line, and motion in 2D would be projectile motion. We will pick up these discussions, but I think we will spend some 8 to 10 lectures on one-dimensional motion. It is very, very interesting. Right? That is all for today, boys and girls. Have a good day.